All right, we have the first three problems on the review assignment. These are non-calculator and they are advanced integration assignments or problems. So the first one is integration by parts, and it's a perfect one to be a tabular problem. And you could use a tabular situation here because you've got a cyclical, not a cyclical, I shouldn't say that, an x squared that will differentiate away to 0, and then the sine one is cyclical. So what I do is start with your x squared and your sine x as your two parts, and then you integrate away x squared to 2x to 2 to 0. Then you integrate sine, you integrate sine to negative cosine, which integrates to negative sine, which integrates to cosine. And then you multiply, and you ignore this sign here, and you ignore this 0 here. You multiply x squared times negative cosine, 2x times negative sine, and 2 times cosine, and then you make sure to alternate your signs to positive, negative, positive. So this guy, when you had x squared times a positive times a negative cosine, you get a negative. This guy, when you multiply 2x times a negative sine, you get a positive. This guy, when you do 2 times a positive times cosine, you end up with a positive, and then don't forget your plus c. Number 2 is another integration by parts, but we are not seeing our second part. So that's when we know our second part has to be 1, because we can differentiate ln of x all squared, and we need something that we can integrate. So we're going to integrate dv equals 1. So if our u equals ln of x all squared, we differentiate u to get du times 2 ln of x. Then we differentiate the inside function of ln of x to 1 over x, and I should have also a dx in here. And then 1, of course, integrates to x, so v equals x. So now I need uv minus v du. So uv is going to be the x times the ln of x all squared, that's right here, minus v du. And the beautiful thing about v du is that our x's cancel, this x versus this x. So we're taking minus 2 times the integral of the ln of x, and I always put that integral, or I always put the constant on the outside of the integral symbol to make life easier. Then we carry down the x times the ln of x all squared, and you are welcome to memorize that the natural log of x integrates to x ln of x minus x. But if you don't have that memorized, this here would be another integration by parts. I would have u equals the natural log of x, du equals 1 over x. Sorry, I'm having trouble writing on my tablet. That's du equals 1 over x dx. dv, once again, equals 1, and x, v equals x. So then I have uv, which is x ln of x, minus the integral of v du, so the integral of just 1 dx. So that's how I integrate to x ln of x minus x. And of course I need a plus c at the end. Don't forget that that x ln of x minus x is within a paren because we have to distribute the 2 to both the terms within the parentheses. So I could have left it like this, or I could rewrite it like this with the 2 distributed. Third problem is partial fractions. So basically I take my original fraction here and I rewrite it as a over x plus 6 plus b over x minus 1 because x squared plus 5x minus 6 factored into x plus 6 times x minus 1. So then if I get the common denominator, I get, and then just look at the numerators, I get x plus 4 equals a times this x minus 1 plus b times this x plus 6. Then I need to plug in x equals 1 and x equals negative 6 because those are the values that zero out each of these terms in succession. So if I plug in x equals 1, on the left I get 5, and on the right I get 7b, so my b value is 5/7. If I plug in negative 6, I get out negative 2 on the left and negative 7a on the right. So then when I divide through by negative 7, I get a equals 2/7. So I go back up here and I write out my integral. My a was 2/7, and don't forget to put that out in front of the integral sign to make your life easier. So remember that a went with x plus 6, so 2/7 times the integral of 1 over x plus 6 dx. And then b went with the x minus 1 factor, so 5/7, 1 over x minus 1 dx. Then you just have to integrate into natural log functions. Don't forget your absolute values, and don't forget your plus c.